So I'm sure longer term subscribers will know who you are by now, and but if you have been, more recent subscriber or perhaps missed previous interviews, Neil, would you be as kind as to introduce yourself, your role at Khronos Group, and perhaps just as importantly, what Khronos's mission is?
Sure. Yeah. Hey, Paul. Thank you for the invitation back. It's not often I get invited back, so I'm happy to be
Not
here.
often people want to come back, so there you go.
Yes, but I'm Neil Trevett. So my day job is VP Developer Ecosystems at Nvidia, basically helping developers get to use GPUs. And I'm also the elected president of the Khronos Group. So those two roles, they overlap a lot. And the Khronos Group is a open standards consortium. We're open to any company that wants to join. And our mission is to create open royalty-free interoperability standards that connect applications down into the power of acceleration silicon for things like 3D graphics. That's our actually main core area, but increasingly augmented and virtual reality, and we call that XR, and parallel computation, things like vision computing and machine learning, and we're having fun as we do it.
I can't help but feel just a little bit jealous about the fun aspect, because I've got some people who talk to me like behind the scenes, and they're the kind of people like, yeah, we don't talk, but they'll talk to me, and it's really interesting what's actually been going on, at these companies, and I think, yourself, I think that the world is changing really rapidly with now we're starting to see chiplets, of course, into, future GPUs, which obviously you can't talk about, but AMD's already had pretty much all their product lineup leaked for the next generation. Obviously, multi-CPU cores now are just it's not even a thing now to have 16 cores in your processor. It's really interesting to see how things are. And obviously you guys are kind of trying to make sure all of that communicates and talks to one another and have kind of, I guess, a common language, I suppose. So with that said, I guess a good question for us to start with is, as you mentioned, it's been 18-ish months now since we've spoken, just over. So since then, there's been a lot of goings on with Khronos. Obviously, you guys have invited me to a couple of events and conferences. So I suppose, what are the most important highlights to you anyway, since we last spoke all that time ago?
Yeah, that's you're right. I've been stuck in this room, but there's been a lot going on.
Sadness intensifies.
Yeah. In the graphics, I know graphics is the kind of the main topic here. So in the field of graphics, we've finalized, and many of the hardware vendors have shipped Vulcan Ray Tracing. And that's something we can talk about in more detail. We're finding a lot of pickup in the developer community there. We've been working hard on what we call Vulcan Portability, which is a set of open source tools to complement extensions to enable developers to take Vulcan applications onto other platforms. And the big, most interesting platform for most developers is Apple platforms, because Apple doesn't have native Vulcan, but there are multiple Vulcan applications shipping on macOS and iOS using the Vulcan Portability. And in Vulcan, also, we haven't shipped it yet, but we're getting actually quite close, is Vulcan Safety Critical, which is bringing Vulcan into markets like automotive and self-driving cars, systems that need safety certification. And again, we haven't announced it, but again, we're getting close. ANARI, a whole new level of graphics API, which is higher level than Vulcan, and that's about to ship, and that is heavily involved with ray tracing as well. And then adjacent to the Vulcan rendering API, we now have openXR, which is not driving the GPU, but it's driving everything else that you need for augmented and virtual reality. So, for example, an HMD and all the input devices you have for good UI in XR. And since we last talked, openXR has really crossed the threshold of adoption, and it's being widely adopted now. It's really it's broken through. into widespread adoption. We have companies like Oculus and Valve saying, we're not going to stop our supporting our old proprietary APIs, but all new future development is going to be in openXR. And we have the engines, Unity and Epic now support openXR. WebXR in the browser is using openXR. Applications like Microsoft Flight Simulator using openXR. So openXR has been really has taken off since we've last talked. And then the last thing, probably the last thread on the graphics side of Khronos since we've last talked, there's been a whole bunch of activity around glTF, which is not an API. Vulkan and openXR, they're APIs to drive hardware. But we're finding that these apps that are using those APIs need to get 3D assets in an efficient, compact way. And glTF is a 3D asset format that's fulfilling that need in the ecosystem. And we've had a whole bunch of things going on: compression techniques, new physically based materials, and one of our first verticals using glTF is 3D commerce, and that's now a whole working group in its own right. So that's been a very active area.
Yeah, I have to say, because I was actually invited to that conference and kind of breakdown for the commerce side of things, and it's very interesting, just how these companies, I believe it was IKEA that was a big proponent of it, if memory serves, and they were really pushing, obviously, because it's not just enough of for you to be able to say, oh, I'm buying a sofa just for the sake of argument, but people are very and obviously with the current world events, people are now really starting to shift to online even more and more and more and more and more. So people want to know little things like, how does this look against my curtain drapes? Or is that TV really too big for my wall? And being able to kind of have all of these things where you can literally kind of hold your phone up and get like an image of the TV versus the size and kind of get an idea of how something fits in. It doesn't sound very exciting, perhaps, to like, I want 120 frames a second, 4K, everything ray traced or it sucks. But in actuality, when you're like, do I really want a 65-inch TV, or maybe I should go with a little bit smaller? These are the kind of things that actually, trying to get your tape measure out and pray to the gods and look online for these guides and like, yeah, it's very interesting to see how little subtle things, perhaps to us, are actually really a big deal.
Yeah, I mean, the whole field of 3D in e-commerce, which we've coined the term 3D commerce, is a huge deal, and to eventually billions of people out there will be using 3D, and it's been interesting. Just to get into the 3D commerce, to just reply to your comments there, that lots of the technology pieces have been around for a while. You mentioned IKEA. I don't know if you remember, but they had a very compelling demo you could place IKEA furniture in your front room using a mobile phone. That was back in 2013.
Wow,
it's actually pretty sobering. You say, okay, cool. So where is it? Why aren't I doing it every day? And what we've discovered is there are still technical barriers to overcome, but a large part of the work that the 3D Commerce group is doing inside Khronos is just figuring out the interoperability problems that you have with thousands of companies building literally millions of products a year and trying to get 3D models out through into compelling end user experiences across dozens of platforms. There's all kinds of friction points in that whole process pipeline that's basically holding the whole concept of 3D commerce to scale, to industrial scale, to be pervasive. And of course, where you have friction points, communication issues, essentially, that's where open standards can really shine. So there's a real demand for how we figure out that pipeline. How do we get interoperability, not just at the API and asset level, but at the kind of the guidelines, and how do you create assets and make them usable everywhere? And that's what the 3D Commerce Working Group is working on. I'm going to get the brownie points. I'm going to use the word metaverse first in this interview. Yes, I did it. And as we kind of go towards the metaverse, which is that's like interoperability on even higher level, on unheard of scale, then the work that 3D Commerce is doing to making 3D assets that are genuinely usable everywhere, is going to be a vital ingredient, along with many other things that feed into this whole metaverse concept. So it's very interesting to watch.
Yeah, I mean, you guys in March 2020, you released ray tracing for Vulkan, which also obviously is a really big topic. Ray tracing now, it's kind of taken a life of its own, because obviously Nvidia, I'm sure you can sing your praises your own company to a degree, but obviously you guys really pushed the RTX 20 first. Turing, however you wish to pronounce it, really, I think, you can make some arguments about Turing perhaps not jumping traditional raster performance as much as perhaps some customers hoped, but in my personal opinion, it was a really good pain point to actually further graphics in the longer term. And now we're starting to see like RDNA 2, obviously, have the ability to run its own hardware-based BVH calculations. Intel are going to be doing that with Alchemist, which is going to be very interesting as well. So I guess what I'm trying to say is, do you think that now we're starting to see kind of ray tracing really take a life of its own? Do you feel that, the excitement around ray tracing has really kind of built up? And it also seems now that ray tracing, people kind of felt it was a gimmick, including some developers, but now obviously you guys have been doing a lot of work with ray tracing. In fact, in some ways your ray tracing is actually better maybe even than DirectX in some ways, because you can run some calculations on the CPU. I think we talked about that briefly last time. You can kind of run some stuff. So for example, if you've got like a 5950X, most games don't really use like 32 threads, so you could kind of partition, let's say, 16 of those off to that. And so, yeah, I guess I'm kind of rambling a lot. So, yeah, just how do you feel like ray tracing has kind of evolved over the past, I guess, almost 2 years now?
Yeah, no, it's just like openXR. It's really crossed the threshold. It's now an essential and integral part of the development platform that many developers are using. And it's great to see the different hardware vendors and the different engines, and increasingly the applications, of course, using ray tracing. It will never go back. And I think you were right that in the early days, because the most obvious demos for ray tracing is shiny metallic balls and mirror stuff.
Everyone, it's like the puddles; they need to be shiny. Damn it!
Yeah. But that is the core of what the technology is capable of. I think, as we were talking before, the ray tracing, it isn't all about that. It's a very powerful general tool. It's just one more way that you can interact with your scene geometry, figure stuff out about the scene geometry that you couldn't before, and you can use it in a whole multitude of different ways. It's just a calculation technique. And I think what we're seeing is that the developers are doing the right thing and not trying to do 100% ray tracing out of the gate. Of course, that would be too big a step, but they're finding ways to incrementally add ray tracing into a whole range of different applications. But they're figuring out how to use this general tool and just lift the whole art of 3D graphics up. And I think, as we talked before as well, I know gaming is our main focus here, and you are seeing ray tracing games, but it's not just ray tracing either. I mean, scientific visualization is using ray tracing because you are accurately rendering the scene. And if you're doing scientific visualization, you don't want to have approximations and stuff. Ray tracing gives you the real deal. And so that's a very fruitful area. And we were talking about automotive. There are companies out there now using Vulcan ray tracing for simulating all of the sensors on a self-driving car. So they're doing simulations of how is a car going to use LiDAR, how is it going to use cameras, and there are people building simulators to help train cars. And ray tracing is an essential part of that whole simulation process. So yeah, ray tracing is going to be used in many different ways. Soon we'll stop talking about it as being something special because it's just being used everywhere.
I was going to say, because also, we're talking a little bit of simulation, so we're going to get more into the, and you use the term first, metaverse.
Yes.
But, it's like, with the rise of VR and all of these other things, Epic have been really, and we'll talk more about this in a moment, have been really kind of pushing the metaverse and the narrative. But ray tracing, just in the perspective of being able to have, as you said, a kind of a physically connected world almost, a realistic world where you can spectate stuff, you can jump in and out of things. And I think, it's very interesting. I mean, because we're still also quite early in not only in the software implementation of things and people's understanding of what it can do, but I think also the actual RT cores now, I mean, just like any part of hardware, as silicon kind of progresses and you can kind of add more logic to the RT cores or whatever else, I think it's going to be very interesting. I mean, would you say that we're still quite, kind of in the early days at the moment in how all of this will function, especially as we're starting to see so many different uses for it? I mean, you mentioned just for a moment ago, it can be used in simulations. It can be used, for example, for ray traced audio, artificial intelligence, and that's a very powerful tool, right? It's not just a shiny puddle, I suppose, is what I'm trying to say.
Right. Yeah. No, exactly. No, I think you're absolutely right. I think just like the rest of the graphics pipeline has evolved tremendously over the last 20 years, right? And we haven't finished yet either. All the different shader stages in the graphics pipeline, they've all been subject to intense innovation over the years, and we are absolutely just starting on that journey with ray tracing. And you mentioned Epic, and they're doing awesome work, with particularly with UE5, the Lumen, which is their ray tracing. Some people call it software ray tracing. I think that's a bit of a misnomer, but I think that shows how the whole community, the graphics community, the software side and the hardware side, we're all figuring out how people are actually going to deploy ray tracing technology in practice, and that will enable developers to come up with awesome frameworks like UE5, but it'll also feed back into the hardware folks. So the hardware folks are learning how are people like Epic really deploying ray tracing, and how can we adapt our hardware to help with that. And I think if you look at Nanite and Lumen from UE5, Epic is, again, Epic doing such awesome work. It's like 20 years of graphics research distilled into that into that engine. But they're from the hardware perspective, the hardware guys feel proud to enable Epic to do such awesome work, because in many cases they're enabled because the GPU has evolved from a fixed function rendering pipeline, which is you have one way to render stuff, and that's it. Over the last 20 years, it's evolved into this very general compute device. GPUs can do all kinds of compute alongside rendering, and that is what Epic is leveraging. So Lumen, it's essentially caching surfaces so they can do ray tracing faster. But they're using Shader Model 5. They say it's software ray tracing. It's not. They're not using the RT units all of the time, but they can do to get better quality. But they're still using Shader Model 5. It's still running on the GPU. It's not software as in running on the CPU. But that is awesome. The fact that our GPU pipelines are now flexible and general enough that Epic can basically redesign the whole graphics pipeline, and it still runs accelerated on GPUs, I think it is an awesome step forward. And I think to support advanced frameworks like that, you will see a lot more compute generalization going into GPUs. And ray tracing, as we were saying, I think it is at the beginning of its hardware evolution. At the moment, ray tracing is like quite a large black box. And both DirectX 12 and Vulkan, the black boxes are very similar. And for many folks, that black box is just what you need. But it doesn't yet have the generality of the other parts of the pipeline that have been evolved over 20 years. And I think maybe that might be the direction that the evolution of ray tracing hardware goes, and not just more performance, of course, that will be a thing, but also more generality. But it's a tough problem, and if we knew how to do it, we would be doing it already. But again, it's the interaction between the software community and the hardware community, I think, will kind of show the path forward over the next few years.
I don't remember we spoke about this, but I just want to quickly ask. I know this is not in the questions, but I kind of just reminded me about it because you're talking about the major changes in the rendering pipelines, and obviously we've seen some really big ones over the, I remember back in the days of like, we've talked about this before, but the early days of like the Voodoo cards, and when we started to see our hardware TNL, and obviously then unified shader models came and were like, hi, we're just going to basically change the way that everyone thinks about everything. But obviously mesh shaders have been a really big deal with Microsoft, and they're pushing them. And I'm kind of hearing from the grapevine, and I don't think you can comment on this, but I'm kind of hearing from the grapevine that, developers have been having some difficulty with the implementation because it's basically just a completely different shift in the paradigm. So I know that, from what I understand anyway, some of the developers have just started to kind of use them on the Xbox, and I don't know if they've started to use them on the PC. But I guess what I'm trying to ask you is, what do you what is kind of Khronos in the long term going to be doing in terms of like a mesh shader like feature? Do you guys have something like that? Is it something that you guys are working on? I was just wondering.
Yeah. So the first of all, kudos to Microsoft for getting mesh shaders out there. I think you're right. Is the developers have had some mixed feedback. I've heard that too, but you need to start somewhere. So it's good that we have that first generation out there. We have had a lot of discussions around mesh shaders inside the Vulcan working group, and we do have some proposals in the pipeline, and we have been discussing how to enable DirectX style mesh shaders to also be that code to be usable on Vulcan, because that's a large part of Vulcan's portability role in the industry, is that we enable layered implementations of DirectX over Vulkan. So just like we did with ray tracing, it's good in many ways that you can layer DirectX over Vulkan with very little impedance mismatch. And so that there's a value to having DirectX style mesh shaders. But we've also been getting feedback that maybe some other ways of doing it may be more enabling to a certain class of developers. So we are discussing that as well. We don't have anything that we can announce, but yes, it's a big important topic, and certainly over the next year or so, you will see some stuff coming from the Vulkan side.
I'm very interested to talk to you guys about that, because it's quite interesting, because if again kind of harping back to Turing just a little bit, but it's really interesting because obviously you guys debuted ray tracing with Turing, and you started to do other things like VRS was obviously part of Turing. You guys did mesh shaders was basically part of the hardware. I remember, was it the Asteroids demo? I think it was so interesting just to see. I think you guys had, correct me if I'm wrong, but I think it was 0 to 7 or 0 to 6 in terms of LOD details, and just how, how that works. And at the time, obviously, it kind of, forgive the expression because it was flying through space, but it kind of flew under the radar almost. And, I'm kind of thinking to myself, guys, this is going to be part of a new API standard. It's just blatant. And, I remember a couple of times when I was talking in videos, and I mentioned that it's very painfully obvious that what you guys did was in preparation for the next wave of APIs, because it was really obvious that Microsoft wanted to push these standards for their next generation Xbox. And AMD tried to do kind of something similar with, what was it, primitive shaders or something like that. So I'm very interested to see how all of this shapes up. And I know you're kind of under billion NDAs, so you can't really say too much.
Yeah, but it's an important area because it goes back to what we were saying before. I mean, just zooming out, it's how you can use the GPU for compute as well as graphics, and in fact, what's the difference? The graphics and compute are blurring and becoming one and the same, but the whole concept of mesh shaders, is using the GPU, to generate work and geometry on the GPU rather than being reliant on the CPU. So, it's central to this whole larger trend of making the GPU more generic and more flexible. And this is just one more thread and one more step on that path.
I suppose the next very logical thing to discuss, now that Intel have formally announced XESS, which obviously is an upsampling, upscaling, however you want to say, reconstruction. There's so many different ways people want to say something. I'm going to say upsampling, just for all of our sanity. Nvidia obviously have DLSS 2.2, I think is the latest iteration, which I got briefed on that. It's really interesting. Basically, it's a plugin now for UE and God knows how many engines. And I suppose what I'm trying to say is FSR doesn't use ML, but basically it's Lanczos as a base, and then you've got multiple passes. I actually spoke to AMD about that quite recently, actually. So I guess I've got a two-part question. Would you say that native resolution is starting to become less of a term which is actually important and relevant to the conversation, particularly when it comes to image quality, not just in games, but just as a general kind of rule? And secondly, with Microsoft pushing DirectML or for their upsampling technology, FSR, obviously checkerboard rendering for the consoles and all of this stuff, UE having pretty impressive technology. Do you think that you guys are going to kind of go into this, or do you kind of feel that you guys already have so many different options anyway, with, kind of DLSS and all of this stuff?
Do you mean from Khronos' point of view?
Yeah, from Khronos' point of view.
From Khronos' point of view. Well, okay. So, I mean, don't want to get into the competitive thing between the different technologies, but all the technologies have the same basic idea, right? Which is you can generate at lower resolution and you can upscale to the actual display that you want to drive. And I think that just like ray tracing is a proven goodness now. And there are many folks out there that are using it. There are applications that are deploying successfully with it, and end users are very happy with the results. So it's one more tool available to developers who are developing applications that they want to ship out to the maximum number of users and give those users a good end user experience. Now, this is one more way. If an end user doesn't have a GPU that's beefy enough to drive the full native resolution of the display, that this is a way that they can do it. And in many cases, people prefer the upscaler to native resolution. So it's a very interesting and valuable technique that, again, is past the threshold of is it going to be used? It's being used every day. Does it make native resolution obsolete? I think no, for a couple of reasons. The one is there are applications that you really don't want to be doing this. Again, I was going to use scientific visualization again as the example. You don't want to be doing scientific visualization and you're running it through some filter that is making it look pretty, but not necessarily reality. There are definitely domains where you don't want to do that, and the machine learning backends in many cases have been trained on games, so you wouldn't want to take it into a different kind of domain. Though that will become more generalized, but more fundamentally, we're nowhere near having enough native performance. So it's not like we can say, oh, good. We have enough performance now with scaling. We can all go back and have a rest. That threshold of GPUs are fast enough is still way out over any horizon that we can imagine. So just like Lumen and Nanite on the framework side, this scaling is just another way that we can really use the performance that we have in innovative ways to reach more end users, but it doesn't get rid of the need for more performance fundamentally, because there's so much more we can do with more GPU performance.
Yeah, it's interesting because for some people, and gaming, just for example, is a very personal taste. Like some people, they've still got, just for sake of argument, a GTX 1060 and they're playing at 1080p. They're happy to turn down some settings. They're good with it. They don't really care. But then obviously you've got those people who are running, just for example, a 3080 or a 3090 or a 6900 XT or whatever. And they're playing at 4K, or they're out there, monitor anyway is 4K. And, 4K TVs at the moment at 120 hertz are so, you feel like you're getting them free at this point with like a bottle of cola. Like they're so damn, they're becoming quite affordable. At least affordable with air quotes anyway, kind of affordable, in air quotes. And it's very interesting because, I guess it's kind of what you said. It's like, how much performance do you need? How much performance do you want? Like you could have someone who has a 3090 and they're like, oh, it's not fast enough because I want 120 frames a second, absolute minimum, all the ray tracing at absolute, max and everything else. And others are like, I'm good with my GTX 1060 for the next 2 years. I'm good.
Yeah, and that's good, right? Because there are lots of different types of users, and it's good to have solutions for all of them. But even that person that has the 3090 and wants to crank it up, the developer has held back, right? So smart developers, of course, are always scaling what they're loading into the GPU so it doesn't just grind to a halt. So, but if you gave a developer that was 5 times faster today, they would find all kinds of amazing, wonderful things to do with it. So, it's the ecosystem is very, over the years, it's figured out how to be self-balancing, self-leveling. So as GPUs become more capable, their titles will take advantage of it, but there's all kinds of fallbacks and scalebacks and tools, and scaling is one of them, that we're not disenfranchising people that don't want to spend $1,000 every 18 months on a new GPU. And I think that's a good thing for the industry. I mean, from the Khronos point of view, it's interesting. We don't have an API for back-end scaling. I'm just thinking, why don't we have an API? And of course, we don't need it because it's just part of the pipeline. The developer, you can turn it on or off, but that's basically the only API you need. Other than that, it is kind of a black box. And in this case, it's okay. But what Khronos can do, what APIs in general can do, particularly for the machine learning ones, maybe as this becomes a more general programmable technique that maybe isn't always used on just the back end, the machine learning acceleration, the general compute acceleration of GPUs again, is where the action is. And so the GPU APIs need to continue to figure out how to be more flexible for parallel computation, including machine learning operations.
Okay, so we're going to switch gears totally, because I realized there is one thing we've not actually spoken about, really, and, I guess a while ago it wasn't, maybe something we could have spoken about as much, but Lunar G obviously is something you guys have been pushing heavily, so could you perhaps explain what Lunar G is, why it's so important, and perhaps give us kind of an elevator pitch for it for Vulkan developers?
Yeah, I'm glad you asked that question, because it can be confusing to folks that are trying to understand, for those who care. How does the standardization and ecosystem around Vulkan actually work? Lunar G are a very critical part of that whole development and ecosystem process. So, first of all, they're a separate, independent company. They're not owned by Khronos in any way, nor is Khronos owned by them. They're independent entities, but we work very closely together. And the lineage of Lunar G actually goes back to Tungsten Graphics. I don't know if you remember it, which is 20 years ago. Tungsten Graphics were always very active in Mazer and all of the open source drivers. And then around 10 years ago, LunaG was formed, and throughout its history, it's basically been like a graphics consultancy company, a gathering of many of the best and brightest graphics driver developers, and that they've taken on various consultancy type projects throughout the years. And then when Vulkan was being first created, a lot of folks realized in Khronos that we wanted to do much more with the Vulkan generation than we ever did with the OpenGL generation of APIs around building tools and SDKs. The game had really changed. To be a competitive API, you could no longer just ship a specification, the hardware vendors implement it, and that's it. That's all the developers get. For in this new generation of APIs, you need to have SDKs, with layers for debugging, samples, a whole bunch of stuff around just the specification and the drivers. Now, Khronos, we're a standardization organization. Now, our primary product is specifications, and we love open source, but we don't have a large engineering team to create SDKs and layers. We just don't have that infrastructure. And so when Vulkan was first being created, many of the Khronos members with this insight, and kudos to Valve, who were the ones that were pushing this first. They actually, Valve and now other Khronos members too, are funding the Vulkan-related projects at LunaG, to most importantly to create and maintain and evolve the SDK, which is getting increasingly rich and complex and powerful over time, thanks to both the funding from the Khronos members like Valve and Google and others, but also the expertise of the LunaG engineers. And so now we're in a very fortunate position, I think, where we have Khronos doing all the specification work, and we work very closely with LunaG that in parallel is making sure that the SDK evolves and is in sync with new Vulkan functionality as it ships. And we have a very close relationship. I mean, the LunaG folks are in all of the Vulkan meetings and in all the Vulcan Portability meetings, and they're a full partner. They're coming in with suggestions on what happens to the roadmap, and it's a very positive and productive relationship.
Yeah, because I think it's kind of like the old joke: how do you horrify someone? Create a new programming language and make them learn it from scratch, right? And give them no documentation, or give them a program and decompile it, and all of the functions are just like random, like function 1, function 2. So, as you said, it's very interesting because obviously even console vendors now, like the documentation of their SDK is almost like as important as the SDK itself, right? And Vulkan is so. I think, I think in such a competitive landscape, things are really interesting at the moment in that regard. Documentation has definitely been something that I think that, Nvidia, for example, did really well with like ray tracing. You guys are doing really well in terms of like Vulkan. And I think one of the things that I really like actually about Vulkan, even though I'm not a developer or programmer, it's really nice just to be able to actually have what is essentially all of the functionality laid bare, so you can very easily kind of understand what is going on, what your roadmaps are.
Yeah. But you're right, though. It is a competitive landscape. I mean, Microsoft and Apple do awesome work with their SDK documentation, and actually the console vendors have always done good work there too. If Vulkan is going to be competitive in the landscape, as you say, we need to have the documentation. We need to have the SDKs. You can't do just a spec on its own anymore. So, yeah. So we're lucky to have the good partnership with LunaG to help us get there.
Do you feel that obviously Microsoft have just bought Bethesda, or rather ZeniMax, and obviously they kind of really pushed Vulkan. I mean, I would say Doom Eternal, just for example, the Vulcan ray tracing implementation of that is really damn good. And it's really interesting, actually, how just how optimized their engines are, just in general. Like, I'm sure you could run that thing on like a turnip at this point, and you would still like. I know this is very off topic, but I'm actually testing an RTX 3060 at the moment for like a larger project. And, okay, I admit it's not as fast as a 3080 Ti, obviously, but it's still amazing, actually, that in a lot of scenes, I don't know if you've ever played the DLC for that thing, but my God, there are so many enemies, so many explosions. You just kind of feel bad for your system. You're like, I'm sorry for what I'm doing to you. And even so, it's still getting around 60 FPS on a 3060 with ray tracing on Ultra Nightmare. So I guess my question is, do you feel that, Microsoft might nudge towards like a DirectX kind of philosophy, given obviously DirectX is their ecosystem? Because as far as I understand it anyway, Microsoft are not going to be putting their games on like the PlayStation. Or do you feel that I know Microsoft are quite liberal with how their developers are actually able to approach projects as well. So do you think this is something that, is kind of not concerning, but do you think that could kind of influence things in the future?
Firstly, I have no insider knowledge, so I have no idea what Bethesda and Microsoft are discussing. But I will also note, yes, you're right. I mean, in over the years, both of OpenGL and Vulkan, it has been the Zoom Quake Doom titles that are, in many cases, the flagship demonstrations of what you can do with the new generation of APIs, and we very much have enjoyed working with them and how they highlight what our APIs are capable of, and of course we hope that continues. But if worst case, if they if any developer becomes a 100% Metal or DX12 shop, that's okay from the ecosystem. I mean, the momentum for Vulkan now across so many different platforms and being used by so many developers, it's no longer dependent on any one developer, no matter how awesome they are. And in fact, again, zooming out to the larger perspective, this is the power of an open, collaborative, multi-vendor standard. It's inevitable. Companies merge, they acquire each other, they rise. Empires rise, empires fall. It all swirls around, and the commercial focus, rightly, of companies is a very dynamic thing, and APIs go in and out of favor at different companies at different times. But that's okay for an open standard. We are the thread of continuity through all of that chaos, because we are not dependent on any one company to develop or use these APIs. That is one of the fundamental values of an open standard to the industry. It isn't just going to disappear tomorrow on, because one company or another takes a decision one day or another. Vulkan will be fine, but of course, we would love Bethesda to keep using Vulkan, and we hope that Vulkan would provide value to them. If they don't want to be locked to just Microsoft platforms, then Vulkan is their path to get wider distribution. But of course, that's their own business choice.
I feel very disappointed you did not say that open standards are not Legion. I feel extremely disappointed. I feel that's where you're going. I feel sad. Speaking of though Vulkan being everywhere, so yeah, you mentioned it has picked up a lot of momentum, obviously, and gaming clearly is perhaps the largest demographic watching this, but even things like, for example, Autodesk Fusion, and you mentioned earlier Vulcan SC. So I don't know how many people who here would be so interested in automotive self-driving cars, if I can speak suddenly. But yeah, so could you tell us a little bit more about Vulkan in terms of 3D modeling / Autodesk and those type of applications, and exactly what the differences are between Vulkan and Vulkan Safety Critical?
Yeah, and you're right. It's really interesting to see the professional authoring apps now beginning to invest wholeheartedly in Vulkan. I mean, I think as we've talked before, typically the professional applications tend to move a little slower than the games. The games are seasonal, and you need a new game every season. Else, where are you? But of course, the professional apps need to be take a more considered evolutionary path typically. But now Vulkan has enough momentum, and it's been around long enough that we're seeing the professional apps beginning to use it. And you mentioned Autodesk Fusion 360. That's a really interesting use case. They actually presented it on SIGGRAPH BOF, so there's a video up there if people want more detail. But in that particular case, they were using Vulkan primarily for compute. Now there is some rendering in there too, but they wanted portable compute, and they ended up selecting Vulkan. And now they have a solution that runs portably on PC, Mac, and that's using the Vulcan Portability in the cloud on Linux, and even between CPU and GPU, because they're writing in GLSL, their compute algorithms in GLSL, and they're taking the Spear V that the Vulcan toolchain generates, and they're compiling it down into SIMD code for their CPUs. Even if you have no GPU, the Vulcan toolchain is providing that portability. So it's really interesting to see Vulkan. It's more than just a graphics API. It's a portability solution. Yeah. I just made it up. I should write that down.
You should.
And of course, Autodesk, they do amazing work as well. And so it's really good to see that Vulkan is fulfilling their needs. Another one you didn't mention, I'd like to mention, because this one does use ray tracing. Going back to our previous discussions there, Adobe Substance 3D Stager. This is Adobe getting into 3D. Including ray tracing, so you can compose, for example, a virtual product shot in 3D using Adobe tools. And as you know, they just bought Allegorithmic, so Substance is now.
I use Adobe enough with Photoshop and Premiere. They're getting enough of my attention.
But that's all based on Vulcan ray tracing, so that's another good example, and there are many more. Those professional applications in the pipeline. But then Vulcan SC. Vulcan SC is something a little different. I won't spend too long, but you don't get me started. It's actually a fascinating area. As you're building things that are safety critical, cars being the most obvious example, but soon drones, robots, anything that moves and can cause harm if something goes wrong. Safety critical.
What was it? The Tesla robot or whatever it's called. Although you could probably outrun it, he assures us, and you could probably out bench press it. So yeah, someone's gonna just modify that thing so it becomes like the murderer.
Yes, well, yeah. That Black Mirror episode gives me the heebie-jeebies.
Just anyway. For some reason, I got really into Terminator back in the day, and I'm kind of like, I'm a proponent of AI. I think AI is, a wonderful thing, but there is that kind of part of you that's like,
Yeah, I mean, the company that impresses me is the Boston Dynamics robots. I mean, they're amazing, but you do go, oh God.
I for one welcome our Skynet overlord.
Yeah, but safety. I mean, you need safe design.
They'll be murdering us safely.
3 doors. It'll all work out just fine. But for your self-driving car, there are safety standards out there, functional safety standards. ISO 26262 is the automotive one, and it basically means you have to do a very careful design, and you have to document every step, all your design assumptions, or your failure modes, what are you going to do when the failure modes occur, and it's a very long and expensive process. It's obviously worth it because you want these things to be safe, but writing the line of code is like 10% of the overall cost of deploying it in a safety critical system with all of the testing and certification you have to do. So you don't want any wasted lines of code. You don't want any large APIs lying around that have bunch of functionality that you're not using because you still have to document and test what happens if something goes wrong. So Vulcan SC is a streamlined version of Vulcan that is designed to give you all the Vulcan goodness, but to give you that Vulcan goodness in a way that is easily integrated and tested within the larger context of a safety certified system. So one example is in safety certified systems, you want things to be deterministic. You don't want to be able to throw random shader code at your automotive system that's running Vulkan, and then suddenly you invoke a compiler, because then you'd have to safety test the whole compiler. And what happens if the compiler does something weird and you can import random untested shader code? Essentially, you don't do that in the safety certified system. So Vulcan SC has the concept of offline pipelines, where you create the whole data flow that you want through the Vulkan pipeline, and you create that offline, and you test the heck out of it, and then that's the only thing that you import into the runtime system. So that's kind of just one example of how there's less flexibility than full Vulkan that can take any shader at any time, but it's precisely what the engineers that are designing a safety certified system need. And we've been working on it for quite a while, but we're planning, touch wood, the plan is to have the Vulcan SC shipping this year. That's the plan.
Yeah, I mean, there's a lot of stuff that is happening at the moment with automotive cars. It's very interesting because obviously Tesla essentially kind of blew the lid off of everything. I remember Musk once said something like, "We didn't even think that we would be competitive. We just kind of did it, and then expected like the likes of Ford or Toyota to just kind of take the baton and run with it, but no one did. But now everyone obviously is getting into these self-driving cars. So AI, self-driving, it's going to be a very interesting world in, let's say, 10 years' time to see how, just for example, Musk, I know I spoke to him about him multiple times at this point, but the robot, getting back to them, they're trying to essentially, take over the boring jobs, as he put it. So it's going to be very interesting to see how the workforce of humans just starts to evolve as we start to see, little 5 foot or however tall it is robots start to kind of walk around next to us as well.
Yeah. It's a large part of my personal motivation of trying to get the industry to cooperate together through open standards is I want to see what happens next sooner.
It's true.
Yeah, because if we all waste time reinventing the wheel everywhere, and then we don't move forward so fast. So yeah.
No, definitely. And we kind of spoke about this a little bit earlier, because you guys did make a lot of announcements over the summer. For example, 3D assets, commerce viewers, again, I can't speak, KTX 2.0 textures. So all of this obviously is under the glTF banner. So I know we did speak about this kind of briefly already, but could you just kind of highlight some of the announcements, or rather the kind of elevator pitch for them, and kind of the problems they're trying to resolve?
Yes. So glTF is actually really, really interesting. As we were saying before, it's not an API. So it's not the first 3D format we did. No, we did do Collider over 10 years ago. But for various reasons, Collider is still used, but it doesn't have widespread adoption. But glTF does. I think glTF was the right move in terms of 3D asset formats at the right time. It really fulfilled a niche, a need in the industry, and it's growing in strength and scope ever since. So the original motivation for yet another 3D asset format, because of course there are a bunch out there, OBJs, FBXs. Why did we do glTF? It was really inspired originally by WebGL. And WebGL, putting a 3D application into your web browser, by definition, you have to download your assets over the wire. There's nowhere else to get it in a browser, right? And so the WebGL guys were the first to really suffer from, oh my God, we're downloading this big old OBJ file and it doesn't have any animations and doesn't have any nice materials, and it's it was really holding back WebGL. So we created glTF as glTF1 was a partner to WebGL, and we were kind of looking enviously at the other media data types and what having a good, universally accepted, compact, easy to process format that everyone understood was really creating big opportunities. Music, MP3, you remember Napster, right? Now it's evolved, but that was foundational to the music industry, for better or for worse, and it enabled a whole new usage class for that media type in H.264. With videos, bam, you have YouTube, right, and all these other video, TikTok, and even photos, JPEGs. Even I say, I hope my mum doesn't see this because I keep using her as an example. I can send a JPEG to my mum and she doesn't think about it, right? She knows how to process it and display it and see it. But 3D didn't have anything equivalent, and that's what glTF was designed to be. And then glTF2 was a result of the native application guys saying, hey, we need that too. The web, it's not just for the web that has this problem of this universally understood, easy to process format. But glTF1 was designed hand in hand with WebGL1. So all the materials were just GLSL shaders, which is what WebGL understands. glTF2, the big breakthrough, was all the materials are mathematically defined PBR materials, physically based rendered materials. And that not only raises the bar on visual realism, it makes them completely portable. You can process a glTF file and display it perfectly happily on DirectX or Metal or Vulkan, not just a GLSL-based API. And it's now everywhere. And the last year, we have been very active in evolving the pipeline. There's been two main threads. One is continually increasing the range of PBR materials that you can use in a glTF file. We now have transparent objects, sheen, volume objects, translucency, quite advanced PBR. But the whole industry coming together at the glTF working group saying, what is the minimum bar for PBR materials in glTF that can be processed everywhere? And that's, I think, the big difference between things like the higher end movie renderer systems out there. Is glTF's mission is to be usable everywhere, including on your mobile phone. And so the glTF working group has ended up being this forum saying, well, can mobile phones do this? And we find a way to make it possible. We released that in open source. We can put it into the glTF spec. And so now we have this quite rich set of PBR materials that are truly universal. And I'm going to use the metaverse word again, and it's going to be a vital part of the metaverse. So that's an ongoing, and there's a whole more PBR materials in the pipeline.
I was going to say, wasn't it John Carmack? Correct me if I'm wrong, but wasn't John Carmack? I can't remember the exact quote, but he was saying something. He wanted something like a JPEG, something like a JPEG equivalent in 3D or something like that, or he said that about glTF. I don't remember the exact quote, so forgive me.
Yeah, we've used that as our tagline. I think it's mostly worked. It's confused some people, but we like to call glTF. It's like the JPEG of 3D, because just like my mom can understand a JPEG file, any moment now, my mom's going to understand a glTF file, and she's going to be using 3D, just as easily. Carmack was a very early supporter of glTF, and when we shipped some early versions of glTF, he helped the adoption by being supportive of the concept. So yeah, thanks to John for that. And then the other track that is just as important is, we want these assets to be as small and compact as possible. Again, particularly if you're downloading them over your mobile phone plan, of course, but just in general, right? No one wants big assets if they can have smaller ones that are of equal quality. So we've been working with a company called Basis, Binomial, who have a technology called Basis, which is a very neat compression technology, and it lets us build universal compressed textures. And you have the problem, right, across the industry, particularly if you're trying to span mobile and desktop, all of the GPUs support different native GPU textures. In an ideal world, you would have every GPU in the universe supporting the same compressed texture formats, because then you could just download that compressed texture format and every GPU would understand it. But we're not in that perfect world. So what Basis Universal lets us do, we transcode our textures into a Basis Universal format. And that format has been very carefully designed that you can, on the fly, transcode it back out into any native GPU format without needing to go through a large intermediate expanded file. So not only is the download size less because you've super compressed the textures, you never have to go into a full size image. So your memory consumption on the target device is also radically reduced, often by a factor of 10. And that is, again, the smaller the device, the more vital that is. So mobile phones, if you can
especially
save
those using Chrome.
It's enabling. You can download models and display them that were just not possible before, and now all of that goodness is encapsulated in the glTF extension. KTX2 is a little known but important Khronos standard. It's a texture container format, and all of that goodness is packed into KTX2, and KTX2 capability is now in a glTF extension, so anyone can use it anywhere.
Okay, let's jump to the next topic. Public beta of UE5 is out, and we've spoken a little bit about UE5 already. Nanite, for example, essentially lets you bring in a high poly count model. For example, ZBrush, you can just pretty much plonk it in. That's a technical term. So I guess with this type of technology, Epic's statement, of pushing towards a kind of metaverse where you can have films, entertainment, games starting to build the line. One of the classic, super simple examples I use a lot, but let's just say you're playing as a racing game or a fighting game, and then you can have like spectators, which could be you, your friends, that type of thing. They could basically jump into the arena, so flying around the racetrack or playing Street Fighter or whatever the heck you're doing, almost from a virtual perspective. So how do you feel that this is going to shape the industry for the next several years? Because this is a challenge. We talk about a lot of moving pieces often, and it's not just obviously the game engine that needs to support it or APIs which need to support it. But there's tremendous bandwidth constraints. Obviously, the GPU kind of throwing around gigabytes of data per second, even on low-end GPUs. Obviously, we're starting to see things like sampler feedback now from Microsoft and trying to get data from the SSD, I suppose, to the GPU and actually do DirectStorage to decompress as well. That's another thing I should like to ask you about GPU decompression in Vulkan. That reminds me, that was one of the questions I wanted to add. But so how do you feel that the challenges are starting to kind of all come together here? It's very interesting in my personal opinion.
Yeah, I mean, we've already used the metaverse joke, and the metaverse is a term that's becoming rather overused, and everyone has a different definition of it, what makes it fun. But all joking aside, the idea that many people are talking about when they say the word metaverse is important. It's the basic idea of, my definition of it is it is an evolution of the web, where it becomes persistent and spatial. And as soon as you have that as a foundation, you can imagine all kinds of products and services and interactions on a spatialized web that aren't possible in the current 2D primarily 2D web, and we have WebGL, but that's most people's interaction with the web is still in 2D. If we can make this happen, it would be a very fundamental shift in how we all interact remotely, and that's can be super enabling. But to make that happen, we need so much interoperability.
I can see sadness in your eyes. That's like so many conversations you've been having.
I was talking to someone else, and they were from a different standards group, and we were both saying we seem to be getting busier and busier. And, have you seen that? Yeah, we are. Yes, we're seeing that too.
Bastards keep making stuff that's unique.
But I honestly think metaverse is one example. That's in general, technology seems to be reaching a phase where interoperability and cooperation is needed in more and more places. So it's good news for the standards organizations. We're finding our services in high demand, I guess, is one way of putting it. And the metaverse is going to take it up to an unheard of level. There are so many issues that need to be solved. I mean, there are technology challenges. How do you get up 10 million people simultaneously on a single server? I think that kind of thing is probably going to be solved first by companies creating proprietary products. The true Darwinian cutting edge on how do you just do that stuff. But there's definitely a role once these problems become not R&D anymore, and people don't want to compete on the R&D, but they want to get these technologies out there globally and pervasively so they can build on them as a foundation to create all these valuable services and products and games and environments that we can imagine. That's, of course, the role of open standards. So we need to, I think all of the standards organizations, Khronos certainly, W3C, OGC, Open Geospatial Consortium, because having digital twins and mapping the real and virtual worlds together is a lot of it's going to be geospatial. So the OGC is going to be key, and there are many, many, many other standards organizations out there, and we're all going to be busy, I think, creating standards over the next few years that are putting some of the building blocks in place for this large vision of what the metaverse might be, and eventually we'll discover what the metaverse is, and we'll know it when we see it, probably.
Ready Player One, maybe.
Yeah. In the meantime, all the standards organizations need to be alert as to what problems are creating friction in the industry, and are they solvable? Are they appropriate for a standardization opportunity? I mean, in the glTF group, right? There was an interesting BOF at SIGGRAPH just a few weeks ago, and some very interesting comments. And from that discussion with the wider industry, we're saying, well, if we want to get beyond just more 3D viewers into a genuinely composable metaverse where you can take assets from Half-Life and take it into Fortnite, whatever. How are you actually going to? How is an asset? What does an asset, glTF asset, need to enable that new level of interoperability in its behaviors, not just meshes and materials? It's composable behaviors as well. And so, this is a journey that we're just beginning to embark on, but it's going to affect things like glTF and all of the APIs that we do. So. Yeah, it's good. I like the metaverse. It's job preservation.
Can you briefly touch on what you think of DirectStorage or Microsoft's version of being able to obviously decompress? Because obviously with the Series X, for example, and the PlayStation 5, they've got their own decompression blocks essentially on the socks, which obviously decompress the data, and the GPU essentially does nothing. But with DirectStorage and Microsoft essentially, to my understanding, data which is destined for main system memory, so your PC's memory, basically, DDR4 or whatever it is at the whenever you're watching this in the future, could be DDR7 for all I know. So that is obviously decompressed locally on the host CPU, but data which is destined for the GPU, it's basically decompressed essentially on the CUDA cores or stream processors of the GPU, and then obviously it's copied, compressed to the GPU memory, and then decompressed. So will you guys be doing, I probably got that wrong, but I'm pretty certain that's right-ish. So would you guys be doing something similar for Vulkan in the future? Or are you talking about it at least?
Yeah, no, we're definitely talking about it. And you're absolutely right. It's inevitable. It's going to happen. I mean, the consoles in this case are, out ahead of the PC a little bit, but you're right. Microsoft's working on it, and we are discussing it at Vulkan. It's like mesh shaders. We don't have anything to announce yet. It's probably a little bit further out. But yes, absolutely, it's an important topic, and Vulkan will have it. And we'll have the interesting extra dimension to our solution. It will need to run on, because of course the file system can involve the OS just as much as it involves the GPU. Yeah. So we're going to need to, because we're a cross-platform, we're going to need to find solutions that work across platform too. So your solution on Windows may be a little bit different from how it runs on Linux. But I think at the core of it, from the Vulkan point of view, absolutely you're right. We need a GPU accelerated codec that takes stuff from the SSD and gets it into GPU memory. That will be an essential part of any modern graphics API over the next few years.
I think because my understanding is one of the big hurdles with Windows I/O at the moment is, Windows I/O, basically. It just can't, it doesn't, from my understanding, again, I could be wrong here, so please feel free to correct me, but it doesn't batch the processes of basically when an application, just for example, is requesting textures or whatever, it's not batching those processes up. So basically you're getting essentially tens of thousands of read and write requests from the SSD, and it kind of slows things down. So I think DirectStorage essentially replaces the Windows I/O system when a game is being run. If memory serves, please feel free to correct me on that.
Yeah, I'm not the expert on this, but yes, essentially you're right. It's just a new way of using a file system. So every OS is going to need to adapt to servicing this kind of demand. Yeah, so there's some OS work everywhere, as well as figuring out how the GPU fits into the whole.
You guys trying to do it for Linux and Apple and God knows what else. It's gonna be. It's gonna be. And the lowest common denominators on like cell phones and stuff. It's gonna make things quite interesting.
Yep.
But yeah.
Off your SD card.
And someone's gonna just be using the slowest 50 megabyte per second read SD card. Why is my game not running properly? So yeah, I guess we're kind of wrapping up the interview, and it actually goes back to one of the things you mentioned earlier. So a big mission, as most people at this point understand, with Khronos is obviously the unification of standards and creating essentially software and hardware which can communicate with one another, essentially, and obviously empowering developers so that if you are creating, just for example, a title for the Oculus Rift, it won't just die if you're trying to run it on Vive, because obviously that is an extremely important thing, because people for some reason might get a bit upset if their $700 headset no longer works with the new game that they just bought. But a big announcement a few days ago from you guys was ANARI, which is an analytical renderer, as far as I understand it.
Yes.
So could you perhaps explain a little bit about it and the challenges involved with, say, Radeon Pro Renderer, Nvidia Vistrex, because basically they all use their own kind of, let's say, kind of methods of doing things, but you're basically acting as kind of a common API framework, right?
Yes, exactly. So ANARI, yes, it stands for Analytic Rendering Interface. It's just like some of the other standards we do. It starts with a particular beachhead, but I think it's going to end up being more widely applicable. So I think it's interesting to a bunch of people. But the genesis of it and the beachhead deployment of it, I suspect, will be in scientific visualization. And if you look at the scientific visualization ecosystem, you have a bunch of engine and application vendors, and they currently have to port to different ray tracing renderers from each of the major GPU vendors. So you mentioned AMD has ProRender, Nvidia has VizRTX, and Intel has Osprey. So classic fragmentation problem. The poor Cypress engines and apps up here are having to basically to do 3 ports, and that's a lot of wasted effort. No one is gaining. Those APIs are essentially doing much the same thing. Of course, there's a lot of innovation underneath in the rendering engines, but there's no real value to anyone from having fragmented an API space like that. So standards to the rescue as in this kind of situation, and we formed the ANARI working group, and their goal, and they're getting close, we're planning to ship provisional specs this year, is to create a single API that you can use, in the end, you can use to drive any renderer. And again, the first initial focus is ray tracing renderers, because that's kind of where we started for Cyviz. But there's nothing in the end that got built into the API that says this has to be a ray tracing backend. In fact, you can use any backend you want, and that's the power. So the other really interesting difference to Vulkan, you say, wait, another 3D API? Don't you have Vulkan already? It's a very different level of abstraction to Vulkan. So Vulkan, by design, it's a new level, explicit APIs. You were saying you get to control every nook and cranny of the GPU. ANARI is designed to be much higher level, much easier to use. All you do in ANARI is you build your scene, and then you push the render button. And ANARI will, you can choose what backend you want, whether it's a ray tracer or something else, and it will produce the rendered image for you. So you are completely free from having to worry about all of the mechanics that involve you in a Vulkan application. Now, of course, games on the whole don't want to do that. Games get their performance and their functionality from Vulkan and the low-level control that they get. But if you're a scientist, or a meteorologist, or a molecular scientist, you're not a graphics engine expert. And we want to enable that kind of domain specialist, again, initially scientists, to build their scene and not worry about all of the details on how it gets rendered. And ANARI will enable that. And from the hardware vendor's point of view, it's awesome because we can continue to innovate. All of us, we can continue to innovate. Amazing renderers implemented in all kinds of ways. Locally on your machine, in the cloud. ANARI will shield the developers from all of those details, so we can innovate all those details and competitive implementations. So as I say, we're getting close to shipping the provisional spec in the next few months. And once we have it, I think we will find that there are many other application areas that want to render beautiful state-of-the-art images, but that those in that domain, whatever it is, they're not games engine experts, and they don't want to have to learn Vulkan or DX or Metal. They just want to hand their scene description in memory to ANARI, and ANARI will take care of the rendering. So I actually think ANARI will be quite widely adopted in the end.
I also wonder, because obviously not all games, for example, necessarily require like the shiniest graphics and the most optimized gameplay. But then again, you guys have kind of OpenGL, and you have still been kind of updating OpenGL as a standard anyway, right? So,
but it's even a higher level than OpenGL. It literally is. I mean, OpenGL, you have various, all the API calls to draw stuff. Yeah, it's Vulkan went lower, but OpenGL compared to ANARI, which is give me a scene, I'll render it for you. It's basically that one call. Once you've built your scene, you just push the button and ANARI will go away and do it. It's much higher level than even OpenGL. So, but it's at the level, because the API is being designed by hardware vendors. It is at the level where the hardware vendors can plug in all of their rendering goodness, but the developers can get to it, all that rendering goodness in a portable way. So it's a win-win for both the software guys and the hardware guys.
Well, I think we have been talking for an hour and 20 minutes, and I don't want to eat up pretty much the rest of your morning, because I know you guys are probably like being stalked already with like multiple different calls. So yeah, but it's been absolutely amazing to chat with you yet again. Quick thing, I'm organizing a podcast when I come back from vacation. I can't say who is going to be on it yet because I'm trying to wrangle the person, but it should be really good. They're quite an industry expert. Would you be interested? It wouldn't be so much Vulkan, but it would just be talking about random crap in computer technology and gaming.
Sure.
Yeah.
It's always a pleasure to talk to you, Paul. So yeah.
Don't lie.
It's true.
Can I get that in writing? I could tell my girlfriend.
You have a fax machine? Oh,
no, you are spitting facts. I like it. Anyway, thank you very much again, Neil, for chatting. And yeah, if you have any last messages or something like that, like if you want people to follow specific things or check something out, if you want to kind of mention that now.
As always, none of these standards build themselves. They're all built by people with passion and commitment. So if any of these standards are interesting to you, whether it's at Khronos or any of the other standard organizations, please consider getting involved. You would be very welcome.
All right. And thank you very much.
Of course. No, thank you, Paul. Thank you for the opportunity.